Hey kids, welcome to the class. Today we are going to learn a small topic, that is application of principle of conservation of energy to a simple pendulum from chapter 2 work energy and power. Application of principle of conservation of energy or law of conservation of energy by a simple pendulum. Now this is a simple pendulum and first position is this is the first position. Okay, so the first position is given as B. That is the mean position. This is the mean position of the simple pendulum. And another position is given as A and this position is given as B. C. M is the mass of the simple pendulum. So M is the mass of the simple pendulum and this is the mean position or ground position. Okay. Mean position or ground position. Now, when the bob of the simple pendulum of mass M is at resting position, this B has zero potential. Here B is having potential is equal to 0. B is having zero potential energy. When the bob is displaced to an extreme position A, it gets raised by a vertical height, right? This is the mean position. So, it gets raised by a vertical height h. Here also it gets raised by a vertical height h. Clear? So, when it gets raised, the work done in lifting the bob, the work done in lifting the bob from the B position to this A position is stored as potential energy. So, now, when the simple pendulum is at this position, that is the mean position, it is having zero potential energy. And when the bob is raised to a vertical height h, it is having potential energy there. Now let's see at which all positions the simple pendulum is having potential energy or kinetic energy. And the first case is B position. That is at mean position B. Let's write at mean position B, potential energy. What is the potential energy at mean position B? Potential energy is 0. Why potential energy is 0? Since height is equal to 0. There is no height from the mean position, right? So, the potential energy is 0 since height is equal to 0. And what is the kinetic energy here? Here the bob is having a kinetic energy, that is half mv square. So let's see, V square is equal to U square plus 2AS. We know that V square is equal to U square plus 2AS. What is the initial velocity here? This is the final velocity, U is the initial velocity and 2 into acceleration into displacement. Okay. What is the initial velocity here? The bob is at rest position, which means initial velocity is 0. So 0 square plus 2 into, what is the acceleration here? Acceleration due to gravity, that is g, into height. Displacement means h. So 2gh. V square is equal to 2gh. 2 into g into h, that is 2gh. So we found V square. What is V square? V square is equal to 2gh. Then we can substitute the V square's value in kinetic energy. That is half mv square is equal to half into mass into V square. What is the value of V square? 2gh. Value of V square is 2gh. So now let's cancel this 2 and 2. Then half mv square will become mgh. So what is the total energy? Total energy is equal. Okay, the total energy is potential energy plus kinetic energy. Potential energy plus kinetic energy is the total energy. What is the potential energy here? We have already found that potential energy is 0 since height is equal to 0. So potential energy is 0 plus kinetic energy is mgh, which means the total energy at the mean position B is mgh. Clear? Now let's see the energies at extreme positions A and C. Both A and C are the extreme positions. Okay, that is the there is a vertical. Now let's see the energies at extreme positions A and C. At extreme positions. Both A and C are the extreme positions. Okay, positions A and C. What is the potential energy? Potential energy is mgh. Why potential energy is mgh? Because there is a vertical height. There is a vertical distance above the ground or from the mean position, which is h. So mass into gravity into height. Since h is the vertical height above the mean position, that's why potential energy is mgh. And what is the kinetic energy? Kinetic energy is 0. Why kinetic energy is 0? Since velocity is 0, kinetic energy is also 0. We don't have any velocities here, right? Velocity is 0, which means kinetic energy is 0. What is the total energy? Total energy means what? mgh plus 0. That is potential energy plus kinetic energy, where kinetic energy is 0 and potential energy is mgh. So we will get total energy is equal to mgh. At mean position B and extreme positions A and C, the total energy is mgh and mgh. So what we can conclude is that during the motion of a simple pendulum, the bulb has only potential energy at extreme positions A and C. Okay, bulb only has potential energy at the extreme positions A and C and only has kinetic energy at the mean position B. Okay, and at all the other positions, the body or the simple pendulum has potential energy and kinetic energy. At all the other positions, it has potential energy and kinetic energy. During the motion, it has only potential energy at the extreme positions. So these are the three main conclusions or points which you have to learn thoroughly. Okay.